Welcome to another episode of this tutorial series. In the previous one, we have completed the initialization of a neural network. Now we start to look into how to actually create and train it from the back end. When we click the button on GUI, it will call a start train method in view class. At the moment, there is nothing inside it. First we check if the label data has been loaded. If not, then we can remind the user. If all file loaded, then we disable the train button on GUI so user cannot click it. Also we change the status bar content to training to inform user current process. The actual training process is going to be handled by start train method in controller class. After training completes, then we change back the button status to normal. And also flag that the network has been trained. Let's move to controller class and create start train method. First we create a timestamp so we know when the training starts, this for checking the duration of training. After that we run the delete method from text method to clean the box. First argument 1.0 means start from the first character, the second argument defines the last character to be deleted, which is the end of the text. After that we calculate the number of total checks or refreshes of GUI by dividing number of loops by refresh rate, both numbers are stored inside GUI. We need this variable to show the progress of training. Now we can start the loop for each epoch. I pack the detail of training into another method called train loop. We will look into the details of it later. After each train cycle has been completed, we check if we need to refresh the GUI. So if it is the time to refresh GUI, first we calculate the loss function result, which is a number between 0 and 1, the smaller the more accurate of the training result. We use cross entropy to calculate loss function. Here AO is output result from neural network, where training label set is the targeted result. We use np.sum, and np.multiply and np.log to calculate the loss function. The power of these NP methods is they can do array sum, multiply with just a few lines of codes. Now we can save the result in loss text. After that we append this text into text box by using the insert method. After insertion, we call update method from the text box to update the view in GUI. Below that, we do progress checking. The percentage is got from dividing the current refresh status by total refreshes that is required, and multiply by 100. We calculate run time so far by getting the difference between current time and start time stamps. After that, we update the status bar to inform user current progress and time used. Increment I by 1 to keep the loop progressing. We then call flat turn list bias in controller class and view update bias in view class to update the graphics. So next lines of code is outside of the training loop. They get run after training completes. What they do is to tell user the training has been completed and overall time has been used. Now we can create the train loop method in controller class. This method will contain the actual neural network algorithms. So the first step is feed forward. This method is to calculate network result based on current weights and biases. When it starts, the first set is the training feature set we loaded from training feature data file. Let's look into the diagram. To calculate feed forward, we need to calculate the value of each node, layer by layer. This value is defined by previous node value multiply with weights and plus bias, we call it ZH. After that we apply sigmoid function, this will transfer it into a number within 0 to 1, we call it AH. Now let's go back to code. First we need to clear the lists of AH and ZH. After that we loop through each layer. All the ZH for the training data can be calculated, use np ... function to do multiply, after that plus the biases. Then we apply the sigmoid function on ZH to get AH. Now we define the sigmoid function as the formula. After that we append them to a lists. We also need to redefine the previous set, so the previous node's value become the previous set for next layer's input. This process is all the same for hidden layers, but for the output layer it will be different, so we need to separate them, use the if-else statement. For the out layer we use Softmax function, which is similar to sigmoid, but more suitable for output result. After that we put them into AH and ZH lists as well. Let's see what is a Softmax function. The Softmax function is a function that takes as input a vector z of k real numbers, and normalizes it into a probability distribution consisting of k probabilities proportional to the exponentials of the input numbers. That is, prior to applying Softmax, some vector components could be negative, or greater than 1, and might not sum to 1, but after applying Softmax, each component will be in the interval between 0 and 1 and the components will add up to 1, so that they can be interpreted as probabilities. Furthermore, the larger input components will correspond to larger probabilities. Softmax is often used in neural networks, to map the non-normalized output of a network to a probability distribution over predicted output classes. Let's go back to code this function. Now we need to go back to initial method in controller class to add the two list for AH and ZH. And we also need to remove the return in start train method from view class. It is time to do a quick test. We can see it works fine. On the status bar, it will inform user the percentage and time used. On the top right is the loss function, there is no change. Means there is no improvement in prediction. This is because we only implement the feed forward, but have not done the back propagation part. We will discuss it in next video. Thank you for watching. If you like this video, please thumb up. Please subscribe for upcoming interesting videos. If you have any questions, please feel free to post as comments.